to be doing a simple activity to get an intuitive understanding of the Bloch sphere and how we can use it to represent single qubit gate operations in a quantum computer. This polystyrene ball represents our Bloch sphere. If we place an arrow on it, we can visualize it as a qubit. When the arrow is facing up, it is in the 0 state. When it is pointing down, it is in the 1 state. When it is pointing to the side, it is in a superposition of 1 and 0. The single qubit gate used in a quantum computer can rotate the value of a qubit from one point on this Bloch sphere to the other. We are going to focus on just 3 of these gates, the X, Z, and H gates. To get a hands-on feel of how these gates work, first skewer the ball in the X, the Z, and both diagonal axes. To model each gate, we can then insert the skewer along the appropriate axes and do a half rotation. As we have already heard, the X gate rotates the qubit 180 degrees around the X axis. We can show this on our model by sticking a skewer into it along the X axis and rotating. We see that the arrow originally facing up now faces down. The Z gate is a 180 degree rotation around the Z axis. We can see that for an up arrow, it has no effect. But for a superposition, where the arrow points sideways, the Z gate flips it. The H gate is an 180 degree rotation around the 45 degree axis. This turns an up arrow into a superposition. If we add a second gate, we then remove the skewer and insert it along the axis appropriate to the new gate. We can then string multiple gates together to see what the outcome is on our qubit. For example, this is what happens if we apply X and then H. Similarly, this is what happens if we apply H and then Z. On the next slide, you'll be trying a few different gates.